All right, in this video we are going to solve the solutions of equations with complex root. So we're going to be dealing with various degrees, but for now let's start with this quadratic equation. So if it's a quadratic equation, so we can just use the quadratic formula. Now we have negative b, our b is negative 12, then plus or minus square root of negative 12 whole squared, then minus 4 times a times c. So all divided by 2 times 8. So indeed we are going to be having 12, because negative times negative is just positive. So under the denominator we can just press our calculator to see that we have negative 12 squared, then we have minus 4 times 8 times 5. That's going to be just negative 16. Then all divided by 8 times 2 is just 16. So basically we have 12 plus or minus square root of 16 is 4. Then we have plus or minus 4i, then all divided by 16. So we can then simplify this, that we have 12 divided by 16. 4 goes 3 times, 4 goes 4 times, we have 3 over 4 plus or minus. Then we have I over 4. So these are the solutions for the first equation, quadratic equation. So these are the complex solutions that we have. Now let's take another one. Let's take number 2. Number 2, we have x plus 10 equal to negative 34 over x. So I think here we can just multiply by x throughout, that we are going to be having x squared, then plus 10x, then plus 34. We can just take this 34 to be on this side. So we have this. Then after all, we are going to factorize this, not factorize per se, but to use our quadratic. So we have negative 10 plus or minus square root of, you have 10 squared, then minus 4 times 1 times 34, then all divided by 2 times 1. So our values of x now, when we put that all in, okay, let me not put the square root for now, then plus or minus, then I have square root of, I have just 100 minus, we have 34 times 4, which is 136 over there, then all divided by 2. So we can just say we have negative 10 plus or minus, then what are we having? We have negative 36 over there, then negative 36 over 2. So we have negative 10 divided by 2, going to be having negative 5 plus or minus. The square root of 36 is just 6, but it's going to be negative 6i divided by 2. That is going to be negative 3i. So these are the solutions for this second equation. So, and they are also imaginary. So taking the next one, now we are dealing with a cubic function with 4 terms. Now here we need to factorize if we can, but I think we can group these terms now. If we can just group these ones and these ones, factorizing them separately, like for example the first 2 terms, we can just take the common factor x squared, then you'll be left with just x minus 1. Then the second 2 terms, we can just take the common factor, which is 25, then you'll be having x minus 1. So this is basically that. So since this x minus 1 is a common factor, we can just take x minus 1 as a common factor, then we'll be left with x squared plus 25. So this is basically this. Then on that note, we can factorize this one further, that we have x minus 1, then this one you can just have x minus 5i, and also we have x plus 5i. So this is equal to 0. Then the factors, we have this one, which is the real here, or x is equal to plus or minus 5i. So these are the three solutions that we have. The first one is real, then the other ones are complex. So that is basically number 3. Then let's check number 4. Number 4, we have this one that I think we can just take this 45 to the other side, that we have 4x cubed, then minus 20 x squared, then plus 9x, then we have minus 45, which is equal to just 0. Then I think if we can also group the terms, the first two terms, then the last two terms, that if we can take 4x squared as the common factor, then we'll be left with just x, then minus 5. Then on this side, we can just take 9 as a common factor, then we'll be left with x minus 5 as well. Then we have 4x squared plus 9, which is the first factor. Then the other one is just that one. Then for this one, we can just solve this real one, which is x is equal to 5, or we have 4x squared is equal to minus 9. Then we have x squared is equal to minus 9 over 4. Then our x is equal to plus or minus square root of negative 9 over 4. Then our x is going to be plus or minus 3 over 2i, because this is square root of a negative number. So these are we have this factor, we have this solution, and these are other solutions that we have over there. So let's check another one. Number 5, we have this quite long, but we can see something common over here, which is now we're going to remove it. We have x plus 6, which is our common factor. Then you'll be left with x squared, then plus 4x, then plus 12, which is equal to 0. Then this one, we can just solve it as x is equal to minus 6. And the other one is x squared plus 4x plus 12 is equal to 0. That we know that we can just break this one to be 4x, then plus 4 plus 8. So 12 can be put in this form. Then we have that. Then this one we can factorize to have x plus 2 squared, then plus 8 is equal to 0. That we can x plus 2 all squared is equal to negative 8. Put the square root both sides. That we have x plus 2, which is equal to plus or minus 2 root 2, because the square root of negative of 8 is 2 root 2, but the square root of negative 8 is 2 root 2i. So because now we are going to transpose this one to the other side, then you will be having negative 2 plus or minus 2 root 2, then I. So this is the two solutions we have, then another real solution over there. So these are the solutions for number 5. Let's check if we have number 6. Number 6, we have this one that I think since this one is x to the power of 4, we can say our quadratic formula is going to be x squared is equal to negative b plus or minus square root of b squared minus 4ac, all divided by 2a. So basically that. So just treat this one as just like x, but anyway, because we are treating it as a quadratic formula, I'm going to show you another method if it does apply here. But for now, whatever solutions that we're going to get here, they are going to belong to x squared, because remember, this is not a basic quadratic equation, because this is x to the power of 4. So basically, this is x squared equal to the solutions that we are going to get, and we solve then again. Now, which means now we are having a being equal to 1, then b being equal to 26, then c being equal to as usual. Now, what are we having? OB is 26, so we'll be having negative 26, then plus or minus. Then we have 26 over there, that is being squared, times 1 times 25, all divided by 2. So we are going to press the calculator now. Then we are going to have 26 squared is basically 676. Then we have 4 times 5. 4 times 25 is basically 100. So we have minus 100, all divided by 2. So what are we having now? We have negative 26, then plus or minus. Then we have minus 5. Okay, it's going to be 576 over there. Then if that's the case, we divide it by 2. Then what are we having? We have negative 26 plus or minus. Then square root of 576 is basically equal to just 24, then over 2. Then therefore the answer is negative 26 divided by 2 is negative 13. Then plus or minus, then square root of, okay, 24 divided by 2 is basically just 12. So these are the solutions of x squared. So basically x squared is equal to negative 13 plus 12, or x squared is equal to negative 13 minus 12. So so this is what we have. So this is x is equal to negative 13 plus 12 is negative 1. So the solutions for this one is plus or minus I. Then on this one, negative 13 minus 12 is basically negative 25. So x is now going to be plus or minus just 5i. So we have these, and these are the solutions for this equation, right? So that's basically that. Now let's check. Okay, we also have number 7. Number 7, we can approach it the same way. Ct x squared is equal to the difference of the quadratic formula, or we can also apply another approach, that if this is the case, how about Ck is equal to x squared, so that in the place of x squared we put k. That means this one, since it can be broken down to this, then we have 13x squared then plus 36 is equal to 0. Then in the place of in the place of x squared, we can literally put this k there. So we have k, but this k is being squared. That's generally taking us back to our basic quadratic equation. So we have 13. Then the place of x squared, you can just put k, then plus 36 is equal to 0. Then we can now say with k is equal to, then we use the quadratic formula, that we have minus 13 plus or minus square root of 13 squared, then minus 4 times 1 times 36, all divided by 2 times 1. So but basically we have negative 13 plus or minus, so 169, then minus 36 times 4 is basically 144, then divided by 2. Then what we have negative 13, then plus or minus, that's basically 169 and minus 144 is just equal to 25. So that's it. Then the idea is we have negative 13 over 2, then plus or minus the square root of 25 is 5, then therefore 5 over 2, but no, there's no, is there I here? The idea is 169, 144. We just don't have I there. We just don't have I here because 25 is positive. So we just have this. Now, what are we having? We have minus 13 over 2 plus or minus, of course, I'm just repeating the same thing. I don't know why I'm doing this, but anyway, these are the values of k. The value of k, the first value of k is minus 13 over 2 plus 5 over 2. Then another value of k is equal to negative 13 over 2, then minus 5 over 2. So that's basically that. Otherwise, in short, we can just say 5 minus 13. We know that this is just negative 8. So negative 8 over 2. This basically k is equal to negative 4. Then on this side, we can just say negative 13 and minus 5 is basically negative 18. The negative 18 divided by 2 is going to be negative 9. So the values of k, it's negative 4 and negative 9. But we need to remember that k was equal to that. We can just move back to this one to find the actual values of x now, not of k. So if k is equal to negative 4, so in the place of k here, we can just put negative 4 is equal to x squared. So basically, our x is going to be plus or minus 2i. That's the first two solutions. Then if k is also negative 9, then we can put it in the place of k. Then basically our x is going to be plus or minus 3i. So these are the solutions for number 7. Okay, or else you can just approach it the very same way. I think this one, the first one that we dealt with is easier than this one, because there is an introduction of k and stuff like that that might confuse you a little bit. But anyway, if you catch up, it's okay. Then let's check if there is number 8. Number 8, we are having this one that we know that we are going to multiply each and every term by x squared, that we are going to end up having x to the 4th, then plus 14 equal to, okay, it's going to be 14x squared, then it is equal to 32. But how I wish this one must be your homework or anything that you can do at your spare time. So just apply the very same way and come up with the solutions, or you can comment down below what did you get in terms of finding the values of x. There, that is number 8. So I'm just leaving it for you to do it at your leisure. Now let's get into number 9. Do I have number 9 here? Fortunately, oh yes, I do. So number 9, have this bunch of thing. So x to the power of 3 minus 5x squared plus 8x minus 6 is equal to 0. We are solving the values of x given that the first solution is given as a solution. Now, what do we do there? So if 3 is a solution, that means when you put the value of 3 in the place of x, definitely you are going to get the remainder, which is equal to 0. The fact that this is a solution, so if you put it in the place of x over there, you are going to get 0. So that means it is going to give you the remainder 0. Otherwise, if it gives you something that is non-zero, then therefore x is equal to 3 may not be the solution of this problem. Okay, so what do you do when we have the solution already? So the idea is, if x is equal to 3 is a solution, if x is equal to 3 is a solution, then x minus 3 has to be a factor. Has to be a factor of the given equation. So if this is a solution, then you just take this 3 to the other side so that you find the factor. So since we are factorizing, let's just embark on that. So if this is the factor, it's a factor when it is multiplied by what to get the trinomial, the cubic. So the linear times the quadratic. So you need to have a quadratic now, which is going to be x squared plus bx. And of course, we managed to note, okay, when you multiply this x by what to get x cubed. So when you multiply it by x squared, so that is why we just have x squared. Otherwise we should have having a there, so that we find the value of a. Now the value of a is just 1, since the coefficient of this x cubed is just 1. So x times x squared is just x cubed. So now we are interested in finding the last term now, so that we can be able to find the last term in this quadratic equation, which is also going to be the factor here. So sorry for that. So here it's -3 times what that you are going to get -6. Of course, it has to be +2 over there. So we have that. So the idea is to figure out what is the value of b here, because we are going to solve this quadratic equation as well. There are solutions that lies there. Now the idea is we need to apply this and that, those values that are going to give you the x squared. So we have x times bx is bx squared. Then we have -3 times x squared is -3x squared. If you can just stop there, then therefore you go to your original equation. And take the term that has x squared, because now we have x squared over here. Then you go take the term that has x squared, so that term is -5 the x squared. So the idea is to just associate the coefficient. So the coefficient of this x squared is b, the coefficient of this x squared is -3, and the coefficient of the other x squared on that side is just -5. So then that b is equal to -5 plus 3 is just -2. So basically our b is -2, then we have x minus 3 is x squared, then minus 2x plus 2. So we just have that. So we can then continue now, because we are solving. So the first factor is the first equation, the first solution is this. Then this solution is going to be, you have x squared minus 2x plus 2 is equal to 0. Then you have x is equal to, then the quadratic equation. Then our b is -2. Then you have negative of -2 plus or minus. Then our b is -2. Then minus 4 times a times c, all divided by 2. So our x becomes, and we have 2 plus or minus, then we have 4 minus 8, then divided by 2. Then x becomes, what are we having here? We have 2 plus or minus 4 minus that is just -4 divided by 2. Then we have 2 divided by 2 is just 1. Then plus or minus square root of 4 is 2 divided by 2. Then it's gonna be just I. So we have that. So these are the solutions for this problem. So this is the first solution, and the other two complex solutions. So this is just number 7. So there was a lot to do here, because we had to factorize the cubic function using various methods. Then let's get into number 10. Number 10, we have this one, and we are given that this is the first solution for this problem. So number 10, how do we approach it? If x is equal to 2 minus I, we have this one. So it is wise that if this one is the first solution, then the second solution is the conjugate of this solution. So which means the second one is going to be 2 plus I. So hence we discussed about the complex solutions, that they always go in pairs. So we have this one and also the conjugate of it. So that's just what we have applied here. So we can see that we have already found 2 solutions for these equations, because we are given the complex solution. So it's easy to find the second solution if you only got 1. So just gonna be the conjugate of it. The conjugate here, we just interchange the signs of the imaginary part of the complex number. So that means we are having x minus 2 plus I. Then we also have x minus 2 minus I. So this is basically what we have. Let's just work on this one so that we'll see how to go back to the original equation. So now we are going to expand this one. X times x is x squared. Then x times negative 2 is negative 2x. We also have negative xi. Then coming to this one, we're going to have negative 2x, then plus 4, then plus 2i. Then let's come to this one. Then we have ix, then minus 2i, then minus I squared. This is equal to 0 for now. Then what are we having? We have x squared, then this one, and what? And this one, they are going to give us negative 4x. Then we have this one and this one, they seems to cancel each other. Then we also have this one and this one, they seems to cancel each other as well. Then we have 4, these ones we've already used. Then we have 4 and negative 2, negative I squared. So negative I squared is basically positive 1. So we have 4 plus 1, which is just going to be equal to 5. So let me just write it here. We have x squared minus 4x plus 5. So we basically have this one. Now this is it. So we can now see this is our since this is a cubic function, so we know that it is just like this, which is the quadratic equation. So I think we need now to figure out what makes 25 and what makes x cubed. So in this linear, so x cubed is made by x squared times x, so we can just have x here, and 25 is made by 5 times positive 5, so we need to have plus 5 here. So this is basically what we have. Okay, now we can see that we basically have this one. So the solutions are as clear as this, that the solutions basically we can just go take that one. We can just take these ones. So we take away, this is the first solution, this is the second solution, and the third solution is just the real one, which is what? Which is x is equal to minus 5. So this is it. I think this is gonna be the last one, this one. So what do we do here? A lot. Now number 11, to we have this, and this is the factor of the left hand side. If it is the factor of the left hand side, so we basically have x, we have x plus 2x plus 3, then times, since we have x to the power of 4 here, which means we need x squared here, and also we here, since we are having negative 9, so negative 3 times what to get negative 9? Of course it is going to be times negative 3. So we also have this bx in between. So this bx, let's just apply our smile, our face, our smiled face. We have this one and also this one. Let's just have this one. Can you see that we're now trying to associate the term with x cubed? Because when you say x squared times bx, you're going to have bx cubed, and when you say this times this one, you're going to get 2x cubed, which is equal to, let's equate it to the term that has x cubed over the original term. So we are going to associate the coefficient that we have b plus 2 is equal to 4, then our b becomes just 2. So on that note, we basically have x squared, then plus 2x, then plus 3, then into x squared, then plus 2x minus 3. So this is what we have in the place of b. I just substituted by this b over here so that we can have all these things. And remember, we are looking for the solutions of this. Okay, now the solutions for this, let's just start with this one. We're going to come with this one as well. Then this one, if x is equal to, then if negative 2 plus or minus square root of 2 squared minus 4a times c, then all divided by this. Then you have negative 2 plus or minus, then you have 4 minus 12. You have 4 minus 12 all divided by 2. Then you have negative 2, then plus or minus, then 4 minus 12 is minus 8. Then the square root of minus 8 is basically 2 root 2i, then divided by what? Divided by 2. So you have negative 1 plus or minus root 2i. So these are the solutions of this one. So let's come to the solutions of the other one, which is x, which is negative 2 plus or minus square root of 2 squared minus 4 times a times c. Then we have time divided by 2. So we have negative 2 plus or minus, then we have 4, then plus 12, because negative times negative is positive, all divided by 2. Then we have negative 2 plus or minus, then this is 16 over 2. Then this is equal to, we have negative 2 plus or minus, then this is 4 over 2. Then we have negative 1 plus or minus 2. Then basically the answers is just negative 1 plus 2 or negative 1 minus 2. That means it's what? It's 1 or it's minus 3. So we have these values. These are the imaginary ones and these are the real ones. So we have something of this kind. So I think this one we just got lazy. We could simplify this, we could factorize this one without even going to the quadratic equation, because you can see that the solutions are rational and they are real, rational and simple. So that's basically that for number 11. So if there's anything that you couldn't understand, please just rewind back the video or drop down the comment so that I can do more of your concerns. Thank you.